Hello everyone, welcome to the last minute revision video for IGCSE Paper 2 exam. So these are the content for Paper 2, which contains all the topics of all the units actually. But there are some topics that are unique to Paper 2 only. So these are the topics that you only have in Paper 2. And I have constructed my video revision tape based off of these topics because these are unique to paper 2, and these are the topics that are most likely to appear in your exam. So the first topic is law of conservation of momentum. So law of conservation of momentum applies to both collisions as well as explosions. So when you look at the first question, that is from June 2023, question 4. So here you have a large bird X, trying to catch bird Y. So bird X grabs onto bird Y and flies off together. So for these type of scenarios, my suggestion is to come up with a Bayes equation. So initially both of them were moving, so both of them had a momentum. So m1 u1 plus m2 u2, these are the initial momenta of the two birds, equals, since the large bird grabs onto the smaller one, so m1 plus m2, they fly off together with a common velocity v. The second example would be from June 2022, question 2. So here you have a large object that splits into two, as in undergoes an explosion. So law of conservation of momentum applies to explosions as well. So total momentum before the explosion was 0, and total momentum after the explosion is momentum of P and momentum of Q. So this will be m1 v1 plus m2 v2. And bear in mind, since they move off in opposite directions, you have to take the sign into consideration as well. Next up, you have moment, which is also a unique topic of paper 2. You don't have this in paper 1. So whenever you see a question associated with moment, and if the question is pertaining to principle of moments, always try and identify the pivot. Luckily, for this specific question, the pivot was given here. So based on the pivot, always apply total clockwise moment equals total anti-clockwise moment. So look at the weight of the lower leg. So the weight is trying to turn the leg clockwise. So the weight of the leg times this distance, 0.25, will be my total clockwise moment, and the foot is exerting a force upward. Guess what? This force is providing the total anti-clockwise moment. So F times this distance. So always remember, while applying principle of moments, it's always force multiplied with the distance, perpendicular distance from the pivot. So this was the force and this was the perpendicular distance from the pivot, and if this is the force, this will be the perpendicular distance from the pivot, that is 0.55. Next, you have the concept of double pivot or double support, if you will. So here the foot is resting on two supports, support A and support B. This was the question from November 2023, and there was a similar question from Jan 2012, a really long time back. But if you compare these two, you'll see it's more or less the same concept. The question was, why will fisherman A have to exert a greater force? So the force from A is greater than the force from B. Similarly, the question asks why is force X greater than force Y? For these questions, since the foot is in equilibrium and the pole is also horizontal and in equilibrium, the total clockwise moment is equal to the total anti-clockwise moment. Since distance from force to the center of gravity of the fish is smaller, if distance is smaller, the force will be greater. Next, you have Newton's third law that you only have in paper 2 again. So the two cars engage in a collision and they exert the same forces on each other. Why? This is Newton's third law. Every action has an equal and opposite reaction. The red car exerts a force of 5 Newton on the yellow car, and the yellow car exerts the same force of 5 Newton but in the opposite direction. And there are some features of Newton's third law pair forces. The forces must be equal in magnitude, opposite in direction, same line of action, must act on two different bodies. This is so important, everybody, because when you look at this example, a book is resting on a table and these are the two forces acting on the book, the weight and the normal reaction force. Even though the two forces are equal in magnitude, opposite in direction, same line of action, but these two forces are not Newton's third law pair forces. Why not? Because for Newton's third law pair forces, the two forces must act on two different bodies, like in this scenario. So this was body 1, this was body 2, right? That these two forces were acting on these two different bodies. But over here, both of these forces are acting on the same body. So this cannot be Newton's third law pair force. Then you have static electricity. So this woman rubs a balloon on her hair. So what happens with static electricity is, for any given question, there is a transfer of electrons due to friction. Transfer of electrons due to friction. And let's say if the balloon becomes negatively charged, what happens is electrons are transferred from the hair to the balloon. And guess what? Since the balloon gains electrons, the hair will lose electrons, making the hair positively charged. So once there is a transfer of electrons, the balloon and the hair will have opposite charges, right? Equal amount of opposite charges. And we all know opposite charges attract each other. This is why after rubbing, the hair tends to cling onto the balloon, because they have opposite charges and opposite charges attract each other. Then you have some applications of static electricity. One of them would be electrostatic paint spraying. The droplets of paint are given the same charge as they leave the sprayer. Explain why this is an advantage. The droplets of paint are positively charged. The object being painted is given a negative charge. Explain why this is an advantage. So, two things. All the paint particles are given the same charge. Why? Because like charges repel each other and the paint particles spread out, covers a wider area, gives an even coat. And the object being painted is given a negative charge to that of the positive charge of the paint particles. Why? Because opposite charges attract each other, so less paint is wasted, plus the paint can reach tight corners. Then you have some problems with static electricity. While refueling an aircraft or a tanker, the fuel can rub against the rubber pipe and become statically charged. So if the potential difference is large enough, a spark can cause an explosion. Then you have sound waves. For sound waves, these are the main topics that are covered in sound waves. You need to know the human audible range, that is 20 hertz to 20,000 hertz. This is the range of human hearing. Then you have an experiment to investigate the speed of sound in air. Then you need to know the relationship between pitch and frequency, and you also need to know the relationship between amplitude and loudness. So I have covered all of these here. So let's say this time is, let's say, 1 second. Okay, also this time is 1 second. So let's count the number of oscillations you see in 1 second. So this is 1 oscillation, 2 oscillation, 3 oscillation. So since you have 3 oscillations in 1 second, the frequency is 3 hertz. And since you have only 1 oscillation here in 1 second, you have 1 hertz. So frequency is always the number of oscillations per second in 1 second, right? And this one has a higher frequency. Frequency is related to pitch. Higher frequency means higher pitch. This has a lower frequency. Lower frequency means lower pitch. So pitch and frequency is separate from amplitude and loudness. Let's look at the second section about loudness. For loudness, you have to consider the amplitude, and amplitude is always considered from the equilibrium position. So here the black line is the equilibrium position, right? So this is the maximum displacement from the equilibrium position, and this is my amplitude. Now if you compare the two sound waves, this has a higher amplitude, and higher the amplitude, the greater the loudness. But this one has a lower amplitude, meaning it's a quieter sound. Next, you have an experiment to determine the speed of sound waves in air. So this method relies on the concept of the difference in time between seeing and hearing. So you see something almost instantly, but it takes sound some time to travel, right? So the whole concept of this experiment is based on the time difference between seeing and hearing. You can pause the video and go through this. This is a very common experiment. I'm pretty sure you must have seen this before. Then, investigating sound waves using oscilloscope. Super important, everybody. Now, these type of questions can ask you to calculate the time period, right? So, for that, you have to count the number of oscillation, or how many squares are there in one complete oscillation. So you start counting from here. So this is 1, 2, 3, 4, 5, and 6. You have 6 squares for one oscillation, right? And these 6 squares represent one time period. So if this question asks you to calculate the time period, so the time is 6 squares times the time for 1 square. So you are counting in the x direction, right? So consider the x direction. In x direction, 1 square gives you this value. So the time period will be 6 times the value of 1 square. That is 5 times 10 to the power minus 6. And once you have time period, you know the equation that links time period with frequency. So once you have the time period, you can just easily calculate the frequency using F equals 1 by T. Sometimes with oscilloscope questions, a question might ask, how can you show more number of cycles or fewer number of cycles? You do that by adjusting the time base. So I have a question here, how to show more or fewer cycles on the oscilloscope screen. To show more cycles, you adjust the time base and increase the time base. And to show fewer cycles, you adjust and decrease the time base. Please remember this. Next, you have energy resources. So I have some energies listed here. These are either renewable or non-renewable, and all of this comes with advantages and disadvantages. You can pause the video and go through this. This will be extremely useful. And again, a core content of paper 2. Then you have change of state and change in temperature. So let's say you have a solid object, maybe an ice cube of ice, an ice cube. You start heating this and you plot a graph of temperature against time. This is for heating again. So the ice, the temperature of ice increases, but the moment it reaches, let's say, 0 degrees Celsius, it starts melting. That is, there is a change of state. And always remember, whenever there is a change of state, there is no change in temperature, because all the energy being supplied is used to break the molecular bonds. So until all of the ice turns into water at 0 degrees Celsius, the temperature remains constant. Once you have water, the state has changed, then you heat it up, and then the temperature starts increasing until you reach 100 degrees Celsius again. This is a boiling point, meaning there is a change of state. And like I have already mentioned before, whenever there is a state change, there is no change in temperature. So the temperature remains constant until all of the water turns into steam at again 100 degrees Celsius. So here you have water at 100 degrees Celsius and you have steam here at 100 degrees Celsius. So until all the water turns into steam, the temperature does not change, it remains the same. And once all the water has turned into steam, then you heat it up and then the temperature of gas or steam increases. The same thing happens when you are cooling it down. So let's say you have gas, you cool it down, it undergoes condensation, which is again a form of state change, and when the state is changing, the temperature doesn't change. So it doesn't necessarily have to be with, let's say, water. It can be with chocolate. So that was an actual exam question. So chocolate was in liquid form, you start cooling it down, the moment it starts solidifying, the temperature remains constant, because as always, when the state is changing, the temperature doesn't change. Then you have change in temperature. Whenever there is a temperature change, there is um, transfer of thermal energy. And let's say temperature is changing over here, right? As well as here. So in either case, whenever the temperature is changing, there is a transfer of thermal energy. And the equation for transfer of thermal energy to or from a body is always E equals mc del theta, where E is the thermal energy transferred to or from a body, m is the mass of the substance, c is the specific heat capacity, and del theta is the change in temperature. Always remember, uh, you don't have to convert del theta into Kelvin, because the value of del theta is the same in both Kelvin as well as degree Celsius. Then you have electromagnets. But first, let's take a look at two wires carrying current in the same direction. When they are carrying current in the same directions, their magnetic fields interact in such a way so that they attract each other. So you see the two forces, they're towards each other, they attract. But if two wires, straight wires, carry current in opposite directions, their individual magnetic fields interact in such a way that they repel each other. So this has appeared once in your examination. Look at these two diagrams. This is the side view and this is the aerial view from top. And if you have a single piece of wire, the magnetic field around a single piece of wire is always concentric circles. So this will be the shape, and the direction of the magnetic field is found out using right hand grip rule. Then you have magnetic force on moving charged particles. This is not a very common topic, but you do have this in your specification. Always remember, the direction of motion of a positively charged particle is the same as direction of current, but the direction of motion of a negatively charged particle is in the opposite direction to that of the current. So this positively charged particle is entering this magnetic field, cross means into the paper. So if we apply Fleming's left hand rule here, current is to the right, magnetic field into the paper, so the force on this charged particle will be upward. This is the direction of the force. That's why it deflects upwards. Same thing for the negatively charged particle. So it's going to the right, but the current is in the opposite direction to the direction of movement of a negatively charged particle. So current is to the left, magnetic field into the paper, so the force on it will be downward. This causes the charged particle, negatively charged particle, to deflect downward. Then you have transformers. So transformers are used to step up, that is increase, or step down, that is decrease the voltage. So you have two coils of a transformer. One is primary coil, the other one would be secondary coil. So how do you identify which one is the primary, which one is the secondary? The coil that is connected to the power supply is always the primary coil. So you see it's an AC power supply. Transformer only and only works with AC. So a common question is, how does a transformer work? So the alternating current produces a changing magnetic field. The core strengthens the magnetic field. There is a change in magnetic field, flux linkage with the secondary coil, or the field interacts with the secondary coil, which induces a voltage. A transformer will never work with a DC supply because DC supply will produce a constant magnetic field, but transformers require a changing magnetic field. Then you have HR diagram. So the y-axis of the HR diagram can be absolute magnitude. What is absolute magnitude? It is the brightness of a star from a standard distance, measured at a standard distance, as opposed to apparent magnitude, that is just the brightness of a star when seen from Earth, or how bright the star appears, that is apparent, but the brightness at a specific or a standard distance is called absolute magnitude. Now this bit is the main sequence, and you can see the main sequence is also a range of temperatures, from stars ranging from very high temperatures to very low temperatures. So since the range is very high, you have a logarithmic scale. So the x-axis of the HR diagram can be colors or temperature, but remember the temperature increases to the left. Okay, now you have to remember the sections of the HR diagram. This is main sequence, this is giants, these are supergiants, and these are dwarfs. So if you want to know the evolutionary process, so a main sequence star turns into a red giant and then eventually turns into a dwarf. All of these are given in extreme details in the fact sheet. Go through it very carefully. Then you have the Big Bang Theory. The most common question from Big Bang Theory is the evidence of Big Bang. So you have two pieces of evidence of Big Bang. One is CMBR, the other one is redshift. I think you already know the detailed points by now. Then you have Doppler shift calculations. Light is received on Earth from a distant galaxy. The longest wavelength of light arriving at Earth from galaxy is 561 nanometer. A lamp on Earth produces the same light with a wavelength of 550 nanometer. Calculate the velocity of the galaxy. So whenever you come up with these values, always remember the equation del lambda by lambda equals V by C. At this point, I see a lot of students getting confused with what this lambda would be. Lambda is always the reference value of Earth, the actual wavelength, right? So the difference in wavelength is 561 minus 550. This bit is very easy. Divided by this is the confusion, everybody. What would be the lambda? Because I have two lambdas here. So the reference value, the actual value, is always lambda. This is 550 equals V is the velocity. It's also called the recession velocity, the velocity with which a galaxy moves away. divided by c is the speed of light, which is 3 times 10 to the power 8. You don't have to do any conversions with the units because the nanometer in the numerator and nanometer in the denominator gets cancelled out. So no need for conversion in these questions. Then in paper 2, there might be questions that ask you to investigate a relationship, or in simpler terms, describe an experiment to determine the relationship between two quantities. So the very first thing you need to identify is the independent variable, then the dependent variable, and at times you are also asked to identify the control variable and how you keep it constant. And in any experiment, you always repeat the measurements and calculate the average. Thanks for watching. Good luck with your exam.